So first, maybe about us. First, let me introduce myself, and then Anže will introduce himself. For those of you, some of you may already know us. So my name is Mitja Robas. I'm with Nil for more than 20 years. Went through all the, let's say, technical departments or sort of, let's say, things that I had to do, from customer support, from the networking, and lately for the last, I think, 9 or 10 years, my focus is more on data center stuff and also, let's say, clouds, which means also public, hybrid, and also, let's say, up to the application level, because my background is actually in software development. This is what I studied. And I used to work, I did actually software development, but it was quite a long ago. The reason there is a minion representing me is that probably you can see behind me, there are also minions. I love those guys because they are cute. And I have 2 daughters that love them, so I have to love minions. That's shortly about me. So Anže, you can.
So yeah, my name is Anže. I've been with Neil for 15 years now. I've also spent 5 years in South Africa, dealing with South Africa's biggest service providers. I'm at Neil, I'm in the role of an IT architect, but mainly I'm focusing on data center technologies and automation. On the personal side, I have a daughter and a son, so it's never boring. I love basketball, and this is my, let's say, these are my recharging moments. And yeah, I'm more of a, let's say, summertime guy, so I really enjoy the seaside, anything that has to do with seaside activities.
I'm very similar. The difference between us is that he's the tall guy and I'm the small guy, let's say. Shortly about the company, NIL, and of course also about, let's say, Concha, which NIL is part of. So for those of you that might not know the company, so we do advanced, let's say, IT solutions, the services, that being also managed services, consultancy, we do trainings, we develop content for the IT solutions, the technologies, the products, a lot of things, a lot of, let's say, areas of expertise. Both of us have more of focus on the data center and cloud stuff, which means also automation. But we are not, let's say, we are not software developers. We have software developers to do the software development. We are more like an SMEs that help them translate from, let's say, infrastructure world to the software development, so they can do the automation part. Yeah, and then of course the core or what was the root at Nil was networking. So we still do that stuff, and that's not only physical networking, that's not only wide area or local area networks, it's data center fabrics, which might be virtual, using software-defined networking solutions. We have a lot of emphasis on IT cybersecurity. We have our security operations center also. And yeah, we also deal with, let's say, user-facing technologies, which is modern workspace and user computing collaboration. We design, implement, also support and manage those solutions. The headquarters of NIL is in Slovenia. We have offices also abroad in South Africa and in Dubai. For those of you that may already know, or those that don't know, since 2019, NIL was acquired by Concha Group. So there are other companies within the Concha Group in Denmark, Germany, Netherlands, Norway, Sweden, and of course we are in Slovenia. Those are the headquarters, let's say. So there are a couple of companies, we work together, we also share knowledge. Yeah, that's shortly about NIL. Okay, if we move on to the NIL and the partners, which is basically vendors which we deal with, or we support, implement, design solutions. Of course, there's Cisco, for which we are gold partners and an integrator. Then we are also Microsoft Gold Partner, which means not only on-prem solutions like Exchange and Active Directory and SQL, but also Azure and Microsoft 365. Yes, we are also VMware principal partner for different different technologies. We have expertise in networking, in let's say, good old plain virtualization, end user computing, as mentioned, automation, their cloud portfolio, and lately also the topic we're gonna talk about today, the cloud native, let's say, portfolio, which is Tanzu. And then of course there are other partners like Palo Alto, Veeam for backup. We do storage, primary, secondary with Pure. We do Extra Hub for advanced analytics of the network traffic and the applications. F5 for the load balancing and application load balancing. I mentioned that we at NIL, we do Azure from Microsoft. But since we are part of Concha Group, there are other companies within Concha that also do AWS. So from the portfolio perspective, we can say that we also cover AWS. Okay, so what's the agenda? Shortly, we're gonna go through, let's say, 3 topics. First will be about the shortly, let's say, an overview of container orchestration market, and the second one will be we're gonna discuss or pinpoint the key challenges, mainly technical challenges in container orchestration, because there are multiple options, and as we'll see, it's not only about orchestration, it's much more than just, orchestration. But yeah, we'll discuss that when we get to that part. And of course, last but not least, because at the end of the day, it's not just about technology, how sexy it is and so on to implement it, but it's also, of course, does it bring any new revenue, or does it, let's say, can we cut costs from whatever aspect and perspective? So the first part, as said, container orchestration market overview. So when we talk about the containers, we can start discussion with how, let's say, the applications or the workloads actually evolve through time. So I'm that old that I still remember the physical. I don't know if Anže remembers that. He does. He's nodding. He's actually on camera. Yeah. So physical, let's say, workload, which meant that there were monolithic applications, physical servers as a unit of scaling. So point being, if you had to add resources, basically you had to add physical servers to be able to serve more users. And the lifespan was years. So yeah, the application was developed, it was deployed, and then of course maintained, but it lived for years. Second, let's say when things became more, let's say, or evolved, or there was a driver in a business that the deployment management and all that should be more flexible, the virtual machines concept came up. So this means hypervisor virtualizes the hardware, and virtual machines on top are the unit of scaling. And basically it means that we can scale from the application instance perspective. We scale by adding the VMs. Of course, if the physical server doesn't have enough resources, we need to add a physical server, and so on and so forth. The lifespan is a bit, let's say, shorter than with the monolithic applications, because we can more easily scale the applications, so more workload, so from months to years. And yeah, so we are more flexible, but of course it also brought some challenges that maybe were not present before. The next stage, containers. So what do containers do? They actually virtualize the OS. So the unit of scaling here is actually application or service. So it's, let's say, you could say it's a bit more lightweight than virtual machines, because each virtual machine has its own OS installed, which needs to be managed and so on. With containers, they actually share that. And yeah, we scale by adding the services or applications. Lifespan, yeah. because it's also faster. We are faster with deployment of that. It's a matter of minutes to days. And then the last stage, let's say, might be that serverless, let's say, workload abstraction, which means that it's not only about the OS that gets virtualized, but also the application runtime. So point being that really the unit of scale is the resources. So basically, we talk about even more granular approach to scaling the workloads. Lifespan, because we can even faster deploy, and of course also not only deploy new, but also take offline, let's say, existing. Its lifespan, it can be a matter of seconds to minutes, which means because it's seconds to minutes, it's also easier to scale for the peak workloads. So let's say if you're a web-based shop, and if we'd be in the USA during the what's that, the Black Friday, you know, because you can spend in a matter of seconds adding the resources, so scaling the application is much faster compared to the first, second, or even the third one. Why do we even need to think about the containers and all that? You see the graph, it's showing how the deployment of the containers has exploded since 2016. There's also the way of how the approach of how the applications are being developed and also deployed. The thing is, with the VM, you had application within the VM. So you had to add another VM and another VM. Now, within, and it might be that the application was, let's say, multi-tier, being there was a SQL database, there was an application tier, and there was a front end. So let's say typically three-tiered application architecture. With containers and serverless approach, you get more granular. So now we talk about the functions, let's say, and you can use functions and combine the functions which are, let's say, run within the containers into an application. And that's why also we have more containers compared to a VM. Point being, a single VM could be like 10, 15, or 20 containers represented by 20 containers when the application gets to be containerized, let's say. And this is the trend. So however we may resist and be against this, the fact is that basically all the vendors of the applications are also moving into that direction, or already have moved, which means that also if we are, let's say, old school, not in a bad sense, infrastructure guys, sooner rather than later, we'll need to deal with that. And that means we'll need to manage this environment. Yeah, so what do we have here? So when we start, or if you start exploring containers, Kubernetes, cloud native, you'll see there are so many different terms and terminology used. So it's not only containers. Container is just like, if I can be very, very simplistic, a container is something like a virtual machine. A Kubernetes is something like, let's say in VMware's world, vCenter. Cloud native is the way how the applications are developed. So these are like frameworks or the way how the application is built. And then we have DevOps, Agile, continuous integration, continuous development. So all sorts of this terminology, terms being used, and all that is valid. So all that is actually part of this story. So it's not only containers. Containers are just a smaller part of the story. Necessary, important, but just part of it. Kubernetes, likewise. There are other tools which are part of this story. Okay, so why Kubernetes and what does it do? So as I already mentioned, if I'm oversimplifying, basically the Kubernetes is what to the containers is what the vCenter is to virtual machines in VMware world. So now, point being, you see on the slide, it says it's de facto container orchestration platform. Why? Because there are multiple, like Mesosphere, Docker Swarm, but it's most of those let's say, deploying or using cloud native approach and all that have actually, let's say, standardized on Kubernetes. So that's why we're going to talk, or that's why it's kind of like, it's a synonym for the management for the containers. So what does it do? We can manage and deploy containers over one or more hosts. It's used also to link together containers so that you have at the end of the day the working applications, because it's built out of several, let's say, containers. It's also used to expose the services. It's used to scale out or shut down, scale down let's say, applications. And it has a lot of extensibility, which means there are extensions that can be added to the platform to provide something like advanced networking, advanced load balancing, application observability, and so on and so forth. You can go forward.
Okay. So what basically happened in the last 3 years is that all of the, let's call them traditional enterprise vendors such as VMware, Cisco, Pure Storage, Palo Alto, Vim, and F5 started to embrace Kubernetes. And in the last 3 years, all of these vendors basically invested a lot of, we're talking about billions of dollars into acquisitions in order to accommodate this Kubernetes, okay? So they're building their services around Kubernetes, and they're using this, as Mitja mentioned before. That's why it's also, Kubernetes is becoming de facto container orchestration platform, okay? So what does this mean? On the slide, you can see basically the major, let's say, offerings from all these vendors when it comes to Kubernetes, okay? These are the most essential or, let's say, basic pillars on which all the vendors are building other services on top, okay? So even if you look at Amazon, there are only 3 services listed there. This is just the managed Kubernetes cluster, for example, or you can run just containers, this Elastic Container Service on their infrastructure, but there is at least 12 other products that are addressing these cloud native applications, okay? Palo Alto, on the other hand, they're trying to, their focuses are basically firewalls and security. So they developed the CN series container firewall that you can use in order to, on your container orchestration platform, in order to go deeper into the security space, for example, SSL offloading and so on, so that you can protect the traffic between the containers or instances, container instances as well. Vim made a big acquisition that's of a product called Kasten K10. This is basically a data management platform for Kubernetes, for applications on the Kubernetes cluster and the Kubernetes cluster itself. So it's basically backup, disaster recovery, and so on. F5 acquired Nginx. I'm sure everybody heard of this one. And they're using it as an ingress controller on their, basically they're offering it as an ingress controller on top of Kubernetes. But in the ingress controller is basically a way of exposing services on Kubernetes, so container instances to the outside world. Cisco, it's basically they're trying to catch up. They saw an opportunity with their intersite workload engine. This is based on their Hyperflex hyperconverged infrastructure that they're trying to position it. They're actually developing their own or maintaining their own hypervisor on top of which you can deploy Kubernetes clusters with intersite Kubernetes service. So they're trying to get away from VMware or at least offer a solution that doesn't require VMware, because Cisco didn't have any hypervisors up until now, okay? The Portworx, Pure Storage, they acquired Portworx. This is a software-defined storage that enables, let's say, advanced data functionalities, on the data level. So it's how to encrypt the data, how to replicate the data between different Kubernetes clusters, and so on. They also have the management portion for managing all these different components. So they're basically a storage company, so they're focusing on that portion of the Kubernetes, let's say, container orchestration platforms, okay? Then we have VMware. They acquired a couple of companies. The biggest one was Pivotal, if you ever heard of it. And they launched the Tanzu product portfolio. And basically the basis of all the Tanzu offerings is Tanzu Kubernetes Grid, which is upstream compatible Kubernetes cluster. And then on the other side, we also have Microsoft. The basic thing is the same as with Amazon. It's a Azure container instance where you can just deploy or run one or more container instances, or you can go into the managed, let's say, Kubernetes space where you deploy your own Kubernetes clusters on Azure infrastructure. So this is just the tip of the iceberg, to be honest, okay? And when you start talking about different, let's say, when you start looking at the interoperability between all these technologies, this becomes really, can become really complex. Some of them, like Amazon, Microsoft, and VMware, they're trying to address, we'll see later on, a broader aspect of all the requirements around container infrastructure. But on the other hand, we have, like, let's call them niche players or players that are working in their space, which are pure Palo Alto, F5, and Vim.
Okay, so moving on with technical challenges in container orchestration. So the key ones, let's say. So first, maybe a bit of a background of, let's say, how to say, the not really disconnect, but let's say the two worlds we have in the company. So there are developers. This is what I used to be 20 plus years ago. Yeah, right. And then on the right hand side, we have the IT admins, and both have needs. What developer wants? What did I want as a developer? Well, I wanted to develop and test application as fast as possible, and it should be lightweight and it should be portable. That actually didn't change. It's just that the means of how this is achievable have maybe changed. So with this cloud native approach to developing the applications. So what did I want to do? I wanted to move the applications as fast as possible from development to test to production, and I wanted to have a minimum configuration and footprint, let's say, challenges. And to be honest, when I was a developer, it's the same thing these days with containers, Kubernetes. You have things available on the internet in some stores or whatever we call that, libraries, which you can include in your application, so you don't have to develop things from scratch. That's why it's also faster. And that was also available back then, let's say 20 plus years ago. I used to work a lot with Delphi from Borland. So object-oriented programming with objects and libraries you could download from the internet. It was really, really great thing because I just downloaded and I started using that in my application that I developed. The issue with that is, and was and still is, that from a security perspective, that's the best way to get some Trojan horses, worms and so on, because you never check the code. You just start using it from someone else. And even if you trust that source, it might be kind of fishy, So that's the developer's needs, and also, let's say, the challenges from that needs. It needs to be fast and so on and so forth. On the other hand, we have the IT admins. This is what I've been for the last 20 years, I guess. What do we want? We want stability, because the infrastructure needs to work. And it doesn't matter whether it's physical, virtual, or in the public cloud. It doesn't matter. It needs to be stable, because if it fails, and if we are accounted for that, that can be, let's say, career-moving, career-changing event, let's say. So one thing is stability. The second is secure. It needs to be secure. The third thing, which is also important because everything is connected, is networking and data persistence. So I have, as an IT admin, I have completely different needs than developer. And this is where this clash of worlds, let's say, come together. And as we already mentioned, the whole world is moving into containerized application space, which means that IT admins we get to manage this kind of platform. So that's why we have to do something. You can move to the next slide. Okay, so landscape. Now, we mentioned there is a lot of terminology. There is a association called Cloud Native Foundation, and you have a landscape of all the, let's call them tools, extensions, and so on. There are places, or there's a lot in terms from storage perspective. We mentioned two of them, Veeam and Pure Storage. There's a lot much more. There's a lot in regards to security. There's a lot in regards to networking and CI/CD tools, API gateways, registries, runtimes, and so on and so forth. So it's literally, you can see thousands of options from which we need to, if we go this path of open source and collect and select all these components for the platform on our own, we need to look at all this and decide, and also then live with them.
Yeah, the basic, I mean, open source, in my opinion, is probably the best thing that happened, because it drives innovation and exposes the technology to general public, okay? But if you have, for example, you decided on an open source project and you have any issues, you can open a bug, you file a bug on whoever is maintaining this open source project. But it might be a bit tricky to get this bug gets actually resolved, okay? Because it's a best effort service.
Yeah.
So this is really important. Let's say consideration when you're considering either I will go down the path, do it myself, or I will look at something that the vendor or somebody stands behind it. So it's like a commercial SLA agreement behind the product that I'm using.
Yeah. Moving on. So open source vendors or your homebrewed solution. As we've seen, there are a lot of components, and when you start, there's a twofold or even maybe threefold process in that. First thing is that you need to know which of those components you'd like to select. Second, you need to put them together to have a working platform. And third, which should not be neglected, is this needs to be maintained. What already Anže mentioned, so if there are bugs, yeah, it's a best effort. You don't have guarantee. There's a more guarantee with vendors that they will fix bugs. Of course, with some vendors, you might be maybe more limited to what they implement. Open source is more maybe vibrant and gets you more new stuff. But that's like living on the edge, like the song from Aerosmith, I think. So, point being, there is a picture that shows you, I think it's called therapy in progress. If you build everything on your own, you just need to, what we're trying to tell is open source is good. Open source drives the innovation and all that, but being IT admins in environments, in enterprises that need stable environment, and given the fact that we don't have infinite resources in the manpower on our hands, well, we need to do some kind of a compromise, which means that you probably select vendor 2 or 3 to have a solution, maybe some open source components, but that's it. And that gives you a working solution with which you can live and with which you can manage and so on.
Yeah, so for example, I was working with one of the basically the biggest service provider in Switzerland on their automation, but the smaller portion of the automation project that they did, okay? And their first cloud infrastructure was based, for example, on OpenStack. But after 2 years, they figured out that it was all, I mean, the technology is great and everything works, but the way how the community changes these different components and enhances these different components of OpenStack, this was a big challenge for them, and at the end they decided to go on VMware platform, basically, because there was just too many moving parts. When you try to upgrade something else broke, and you had to, basically, they had a big internal software development team that was actually dealing with all these moving bits and pieces that were presented through these open source projects. So when I started looking at this a couple of years ago, when I started to look at Kubernetes itself, okay, it was in my opinion, it's quite a steep learning curve, especially because you're let's say challenged or presented with all these new terminologies, how the things are put together and so on. But what I found when I was looking for additional resources or information is this diagram that's actually from Gartner. And they kind of prepared or kind of visualized the container orchestration platform. It's like a reference architecture. So what we are looking at is basically the major components of any orchestration platform that you should look at. Okay, so when you look at maybe the most important one. The core of the platform is the orchestration and scheduling, like Mitja mentioned. So how do I orchestrate all my nodes, let's say nodes that are part of my Kubernetes cluster? How do I schedule containers? How do I scale these containers and so on? The next portion, the service discovery and registration. Okay, it's really if whoever was dealing with virtual machines, when they came out, it was, yeah, okay, I can have, I don't know, 100 virtual machines, and then I end up with 200 virtual machines. And then it was, oh, how do I link these services that are on top of virtual machines between each other? Okay, how do I find the service? How do I even manage all these virtual machines? So service discovery, it's really important because in the container world, there's even more container instances running on your infrastructure compared to virtual machines. And all these instances must talk to each other in some way if they're part of the same application or not, okay? The ingress routing, it's also important because I have to expose my services to the outside world, so out of my Kubernetes cluster. So it can be as simple as layer 4 load balancer, or it can go up into the layer 7 load balancer functionalities, including, let's say, web application firewalling and so on. So it's also what I want to achieve and what technology actually offers me these functionalities that I require. The service mesh portion, this one is when you try to, it's how to link all these gazillions of containers or container instances between each other, and how can I assure and see what's going on the traffic level. So basically it's, I can see, I have traceability and performance metrics. So if my application, so for example, my application doesn't work. So which component of my application, if it consists of, I don't know, 50 container instances, which one has problems? Okay, so this is what the service mesh kind of offers in a nutshell. One important thing in the architecture is also the registry. So where do I store my container images that are then later deployed on my infrastructure, so that I can have these container instances up and running? And how do I manage all these images? Okay, one example, probably the most well-known is Docker Hub. But again, using all those images, okay, it's fun. I mean, it's nice because they're there, but do they meet my security standards? What exactly is in those images and so on? And this is where the registry portion comes in. The important component is also the management, user interface, and APIs, okay? Why is this important? Even if you look at the simple enterprise deployment of Kubernetes, you will end up with at least 2, if not 3 Kubernetes clusters, okay? One is for the development purposes, one is for staging purposes, and then the production, okay? So it's how do I roll out these clusters? Imagine if you have 10 or 15 of them, okay? And if you go even further on, you have 5 clusters on-prem and you have 5 clusters on Azure or Amazon or whatever, okay? So this management component is really important, so that I can manage, so the lifecycle management of these clusters is somehow consolidated, it's the same, and that I can assure that all the functionalities that I require on my infrastructure are actually on all the clusters, or deployed on all the clusters. The infrastructure integration and management, it's also important. So for example, I don't know, I will just say I want to use Tanzu Kubernetes Grid, okay, and I want to deploy it on Alibaba Cloud, okay. This is currently not supported because you can deploy Tanzu Kubernetes Grid, so the Kubernetes cluster maintained by VMware, we can call it like that. you can deploy it on Azure, vSphere, or VMware Cloud on Azure and vSphere. So there are certain limitations. If you look at Cisco, they're only supporting currently deploying their container platform on Hyperflex as virtual machines on vSphere, virtual machines or their hypervisor, and bare metal is coming. So this one is also important on which infrastructure I want to deploy the solution and what the solution support. Very important component is also data protection. Okay, if you're coming from the vSphere world, for example, or there's a good, probably the most basic example is you're most probably using Vim, data and recovery products. Okay, you cannot use Vim to properly back up your container infrastructure, okay, and let alone the containers themselves, okay, because you're describing the way you're deploying and describing the application is completely different compared to the virtual machines. So there are new, let's say, products and way of ensuring backup or providing backup and disaster recovery for such implementations. Monitoring, logging, 100% a very, very important important component, so that I know how to monitor the whole infrastructure, so that I can see where do I have certain issues, or if I have issues, do I have to scale out the physical, underlying physical infrastructure, do I have to scale out the application itself, and of course logging. If you end up with, I don't know, a lot of container instances, it doesn't make sense that I have to log in manually to each instance and see the logging. It has to be centralized, and I have to have some sort of, let's say, it's very good to have some sort of correlation so that I can see what's going on. So if I have a problem with the application, it might be on the application level, it might be on my orchestration platform level, it might be on the physical layer, the compute, network, storage. So this is really, monitoring is very important. Security as well, especially when you go across, let's say when you start consuming cloud services, okay, security becomes even more important, because it's even easier to, for example, expose an unwanted service to the rest of the world on the cloud infrastructure, because it's meant to be like this, okay? And it's also the security side, not just the orchestration platform. So are my clusters configured, I don't know, based on the CIS baselines? Maybe they are, maybe they're not, but I have to ensure that my infrastructure is correctly or configured with adequate security. And the policy and governance, this one goes hand in hand with security. As I mentioned, the CIS baselines. Are my clusters configured correctly? How can I ensure that, let's say that I found that I have a container image that has a vulnerability? Can I prevent automatically, without human interventions, that this image gets executed on my container runtime, so that the container instance doesn't even appear? So this is in a nutshell. Okay, and the next portion, basically the last one, is the extensibility. It's okay, so if we look at the, let's say, vanilla Kubernetes cluster that I'm using, there are certain functionalities that are offered off the shelf, okay? But what if I want to extend my cluster, that I will be able to, I don't know, automatically manage all the certificates that applications are using, so that every time I deploy an application, it doesn't matter, development stage or production environment, that application is issued with my internally signed certificate. This is where the cert manager, for example, comes in. And there are multiple extensions that I can deploy on Kubernetes cluster, and it's also how to manage them and maintain them again. So this is really an important, because this additional functionalities enable the software developers to faster or more securely, or let's say, how do we call it? Yeah, it's a faster development at the end of the day, so that new functionalities can be rolled out. And it's as little as possible human interaction when I'm deploying or migrating this application between different environments. So this is just an example. So what I'm using now, this, let's say, reference architecture, is when I'm trying to compare different products as well, okay? So VMware Tanzu Basic, this is a, let's say, a prepackaged, let's call it prepackaged product portfolio that VMware is thinking that will solve certain issues. And we're looking at example, how do these different technologies or components of Tanzu Basic fit into my reference architecture, okay? So we're not going into details in terms of what is what, but the most important thing is if I take Tanzu Basic, I will have to do something, do-it-yourself approach for policy and government, security, data protection. I will have to find something that fits into the whole picture and replace it, basically implement this component, okay? If we look at Tanzu standard, okay, this one includes, you can see these do-it-yourself squares are disappearing because VMware is offering additional tools or basically products to address different portion of my container orchestration platform. So if I go back just quickly again, there's a lot of red squares on this one. On this one, it gets populated with additional, I mentioned SAP Manager, DNS, integration, so that my application, when my application is deployed, the DNS record is automatically created in my DNS servers and so on. And what VMware does is they will offer also enterprise, let's say, support for all these components. One thing is that all the vendors that we mentioned, so pure VMware, what is the Amazon, everything, even Vim, Palo Alto, it doesn't matter. They all contribute back to the open source projects that they're using, okay? Even VMware and actually open sourced certain projects that they were working on internally, for example. So that they're trying to get into a place where, yeah, there is a, in theory, you shouldn't care on which infrastructure you're deploying the application because the functionality is already there. And maybe it's not really the case, yeah, but we're trying to get that.
And maybe one, let's say, fun fact is that the guys that used to be at Google that came up with, let's say, Kubernetes and all that, they're actually now at VMware.
Yeah, that's
Joe Beda, I think. So Beda is in Slovenian language. It means
sucks.
Yeah, something like sucks. Yeah.
Okay.
But just fun fact.
Perfect. Yeah. So what's also interesting is that, let's say with Tanzu standard, you're entitled to deploy Kubernetes clusters across different cloud providers, whereas in Tanzu Basic, it's only the vSphere infrastructure, on-prem infrastructure. So why am I mentioning this? Okay, is because there are certain major deployment stages that someone should consider. Okay, I also found this one on Gartner. The one marked with asterisks are actually something that I added because I also think that they're important. Okay, the first step is definitely, or the first stage is definitely the planning stage. As I mentioned, the most, let's say, basic question is, do I want to have, or do I need my platform to be only on-prem, or do I have to support multi or hybrid cloud deployments, okay? Because this is basically the most, let's say, basic questions when I'm trying to select the correct technology, okay? It's also important that you start planning security of all these different components at the beginning. So in which, let's say, points do I have to insert certain security checks in order for, so that my platform will be secured, let's say, by default, okay? Then there are different deployment prerequisites, is the deployment upgrade and automation, as mentioned. If I have multiple, I don't know, 10, 15 clusters, Kubernetes clusters, there has to be a automated way of managing the life cycle of these clusters. If you're looking at, let's say, if some of you are in the service provider space or you're offering services to other customers, you can imagine if you have 100 customers and each one of them has only one Kubernetes cluster, and you have to manually manage them, it becomes, it's not manageable, okay? So the automation is really important portion. The worker node, network configuration, storage integration, it's on the level of the infrastructure, but when we talk about network and storage, but when we talk about node configuration is, do I really require that so Kubernetes worker nodes and master nodes are, let's say, running on Red Hat Enterprise Linux operating system? Or it has to be Ubuntu, or am I happy with, in the case of VMware, I'm happy with Photon OS. There might be certain use cases where you have to think about this one. For example, if you have some certain, I don't know, backup agents or management systems or whatever, this kind of is important. Otherwise, you just don't care, like you don't care with ASXi. The container registry we already mentioned. It's really important that, in my opinion, it has to be on-prem, and you have to have control over this container registry. On the operate side, we mentioned basically most of them through the reference architecture that we looked at, and the commercial criteria is also important. One thing is packaging. So every vendor is trying to, on one hand, they're telling you, no, this is, if you go with me, there's no vendor lock-in and so on. That's okay, it's bullshit. Excuse my language, okay? They always want to lock you in one way or another. So it's really important to understand what does the vendor offer and how does this affect me. And as we saw in the example with Tanzu Standard and Basic, what do I get in the package that they're offering, okay? The professional services portion, I believe, is also important, but it also depends at which stage you're at in terms of the let's say the skills and the knowledge you have about containers, the infrastructure, the cloud native development frameworks, how do you develop the application and so on. Because there might be, I mean, there might be a need that somebody helps you on this journey so that you get from your current, okay, it's not probably the right word, but for the sake of the argument, the legacy application development to a cloud native so that you can utilize all the benefits of this orchestration platform. It goes again into the managed services. Am I competent enough, or do I even want to be dealing with the infrastructure itself? For example, do I have to do I have a team that will manage this infrastructure, or do I want to outsource it? And it's always the support portion that Mitja and I already mentioned a couple of times. Is if I have a problem, do I have an SLAs for this problem to go away, basically, either through somebody else or through vendor, it doesn't matter. But this is in high level. These are the most important deployment stages and basically the activities when you're thinking about orchestration platform.
To add to the importance of the support, this is not hardware, so you cannot replace it if it let's say breaks. So that's why it's really important to have proper support which means, you know, something from some vendor. Yeah.
Okay, but the orchestration platform, it's just one piece of the bigger picture or the puzzle, okay? If you look at this diagram, we're talking about this portion. So my Kubernetes cluster that can run my containerized workloads, the infrastructure, network, compute, storage, that's all good and dandy. But what about the DevOps practices? How can I implement this? So when you're thinking, when you're looking at the bigger picture, is okay, I have an idea, I will develop the whatever the application I have, I will do it, let's say on my laptop. That's a simplified representation. Okay, and then I will push my source code into the Git. So how does this application that's currently living in my Git as a source code, how does it how do I push it on the infrastructure so that my users can actually start consuming it? Okay, and there are also different aspects on different, let's say, the building blocks of this picture. That's one is definitely security, consistency, so that I can have the same let's say performance, look and feel, the whole thing is consistent, and I don't have to deal too much with if I'm deploying my application into development stage or even production environment. So the things are, let's say, automated as much as possible, okay? So this is the continuous integration portion, which is really important. Is okay, I can do it, Git can do a lot, okay, but maybe I need another tool that helps me with my CI, continuous integration process. It's also the question of which tools am I going to use on this side of the picture. We're not talking about the infrastructure anymore. We're talking about the tools that are supporting my DevOps operations. And then on the continuous deployment side is if I have a source code, okay, it gets built. I do my unit testing. I can also do security. I can check the security posture if my, I don't know, for example, my source code includes well-known, let's say, SQL injections, or if I'm hard coding my passwords into the code itself. So I can stop the process on this level, and of course I can automatically test the application itself. Once this gets through, or let's say that the source code can go into the next phase, is how do I build the container image? Okay, there might be different libraries, languages, whatever you need, whatever the application requires. I don't know, if you're developing in Java, these Java libraries and runtime has to be included into the container itself. So how do I build my containers? Once the container is built, I have to push it into container registry so that it can get consumed on my container platform. Container registry, again, it's another entry point where I can check for security inconsistency. So are my container images, do my container images include some sort of vulnerabilities, for example? And if they do, I can say on the infrastructure level, no matter what the developer wants, or somebody really wants to have this application, I can say on the infrastructure level, if my container has a vulnerability of level high, I will not allow this container image to be run on my infrastructure. So I can already stop it here. And the continuous development is also, okay, I'm happy with my application, for example, on my staging environment. Okay, I will just switch to production. And it's also this, let's say, fancy stuff that comes into play, like blue-green deployments or canary deployments. So I can say certain users with these characteristics will use my application version 2.0, and the others will use 1.0. Once everything is working for the new version, I will just switch all users to the new version of the application. And we already mentioned, so it's the managed portion. It's really important on the platform level and applications. So the infrastructure guys might not understand the whole application, but the application developers, or let's say the operators, will understand which let's say application has to talk to which application. So it's for the troubleshooting purposes and so on, and the observe portion. So how do I see what's going on with my application that's running on the infrastructure, what's going on with the underlying physical infrastructure and so on, so that the user can seamlessly consume the application that I provide, okay? And this is the bigger picture that actually the container orchestration platform enables us to build with additional tools, of course, that we start developing this so-called development security operations practices, okay? So it's automate as much as possible, don't touch it when it gets from different, so there's no human intervention or little human intervention when I switch between different environments. So,
okay, so there was a lot of information, and I have to admit that every time I get involved with this, I'm perplexed like that mongoose on the right bottom side of this slide. The point being, like we've said, the landscape is huge. There are a lot of components, and if you want to have a working solution, we really need to standardize or select just a couple of them, and yeah, trust the vendors. As it was already mentioned by Anže, and then I also mentioned myself, the open source is really vibrant here, so it changes very frequently. And that's why, you know, if you write a Kubernetes blog, it's out of date even before you, let's say, publish it. It seems very complex. To be honest, yeah, probably it is. But then in the end of the day, once you start, or not really start, once you are into this, it gets, so the pieces of the puzzle start coming together. So you get the bigger picture, you understand the areas, the components and so on, and who does what and all that stuff. And at the end of the day, the biggest, let's say, challenge we've seen is to kind of explain that it's not only Kubernetes, it's not only containers, but it's much more if you want to really dive into, let's say, cloud native application development, deployment, and lifecycle.
Yeah, one thing is that you cannot just I don't know, take the application that you have on let's say, monolithic application or a legacy application, package it in a container and slap it on some infrastructure, okay? This doesn't solve anything, it just presents an additional challenges, if you ask me, okay? So when you're looking at this complexity, it's also the portion of, okay, I have to understand what kind of applications do I have? Are they even candidates, possible candidates to be containerized? And this is basically where it all starts.
So yeah, go ahead.
The business, so the business benefits, okay? It's a couple of, let's say, memes, or how do you call them, okay? But the main message is don't jump into this space just because somebody talks about it, you heard about it, I don't know, in the news or whatever. Don't jump the gun, okay? You have to understand what you're trying to achieve and why are you doing this, okay?
Yeah, it's a lot of catchy phrases and it looks sexy and all that, but then at the end of the day, it's like, so what the hell am I gonna use this for, and what kind of benefit it's gonna bring to the business? Point that Anže tried to emphasize is also that this is a process actually. So it's not like that in a month time you'll have your applications, let's say cloudified or whatever you call that, with or containerized and all that. It really requires a thought process, homework, design, some rethinking, and so on. Not that it's not doable. Don't be afraid of that. But it's a process. Point being, it's a process. You know, it's not like from zero to hero in 2 days. It's more like, yeah, it's a steady approach, and you can actually start small, do just a couple of things, address low-hanging fruits, not even the whole platform, maybe just a couple of things, and then start adding the components and build the solution. And then in a certain amount of time, you'll have your fully fledged, let's say, cloud native applications being developed. And another important thing is, don't dive into this just because someone says it's going to solve certain issues, scaling issues. Maybe it's not about that, so don't try solving imaginary, let's say, issues. So really, the thought process, the reasoning why this should be used in real environment has to be done thoroughly.
Yeah, one thing is also important. It's because all this, okay, the cloud native, let's say, story and technologies. I mean that they do come from the, let's say, service providers, such Amazon, Google, and so on. This is where everything basically came into. It was born. Okay. It's also important to understand when you're looking at the solution, all the solutions that we mentioned, or let's say the vendors and their solution that we mentioned, they have certain software as a service components, okay? So the control plane lives in the cloud. I personally, I mean, there's nothing wrong in consuming this such services, okay? But you have to evaluate what's the impact of such service if I lose connectivity to the cloud, okay? Even if it's just the control management portion. So let's say the Tanzu Mission Control is actually a software as a service solution. I connect all my clusters, I deploy all my clusters through this solution, but suddenly I lose my connectivity to the cloud, okay, to this service. What then? This was all the complexity that comes with deploying clusters is hidden with this tool, okay? So if I lose connectivity, is there a contingency plan in order to decouple this integration? And if I'm even capable of managing this, let's say, infrastructure without the management portion. The same go for Cisco with their Intersight story. It's a SaaS, software as a service solution. They have an on-prem solution, Intersight, but the functionality of this solution is not the same. So the on-prem version always lags behind the SaaS version. So yeah, all the Intersight Kubernetes service functionalities are currently only available as a SaaS solution.
one of the imaginary, let's say, issues that cannot be addressed, and I personally believe it won't be addressed ever, is the lock-in thing. So you might hear from vendors or even from the open source community, use this because you're not going to be locked in. Whatever you think about this, but if you're using something from open source or from a vendor, you basically do get kind of locked in because you're using something to which you are attached, or your platform or whatever. So just forget about it. Let's just accept that we'll always be locked in one or another sense. So this is an imaginary issue. Well, I mean, it's real issue, but it cannot be solved with even with this. So that's, if somebody's pitching you this approach because you're gonna solve that, we think it's not gonna be solved.
Okay. So what's the first thing, in my opinion, okay, is that you have to understand yourself, okay? This puzzle with broken eggshell and how to put it back together, I felt like that when I started looking at all these, let's say, cloud native technologies, including what our vendors are offering and so on, okay? At the beginning, as I mentioned, the learning curve, it's quite steep, okay? But once you get the hold of these basic principles and ideas, it becomes, let's say, more manageable, okay? Oops, sorry, wrong button. So how do also NEAL fits into the whole picture, okay? We kind of differentiate the vendors based on their, let's say, roles, okay? So we have supplemental vendors that add additional added value in the whole solution. So for example, Palo Alto Security, F5 is the ingress portion and load balancing, VM backup and recovery, Pure Storage on the software-defined storage layer if you need it, and certain open source project as well, don't get me wrong. But these are the supplemental vendors that enhance my core solution that I'm using. And then there are core vendors, depending on which area, or let's say, in which direction do you want to go. Currently, from our vendors, the only, let's say, on-site or on-prem solution can be built with VMware and Cisco. And on the other hand, AWS, basically Amazon, they're actually, it's a cloud-based provider. I mean, it's a cloud provider, but on the other hand, they're also launching in, I don't know, 2022. This year, they will be launching an on-prem option or version of their managed Kubernetes clusters. Okay, so you will be able to deploy your Kubernetes clusters on-prem. And as far as I know, Amazon doesn't have a lot of services like this. So what I'm trying to say is also that the drive or the need seems to be very big, as Mitja mentioned at the beginning, okay? That enterprises are consuming this, let's say, cloud native technologies on-prem as well. And if you're, I don't know, if you're today, everything is hosted in Microsoft Azure, then of course you go with the Azure services that are offered around the, in their portfolio, okay?
One aspect maybe here, when you're considering the public cloud offerings, even with this cloud native Kubernetes containers, as soon as you start using something which is specific to Azure, of course, forget about mobility to AWS. That's it.
Well, I wouldn't really agree with you.
Well, there's a certain level of effort you need to put in to be able to move it. So but point being, you know, whenever you use something that's specific, or remember virtual machine portability between the hypervisors. Yes, it's true, but if you're using specific hardware, which of course gives you the benefits, you know, on VMware, for example, or even on Hyper-V, forget about portability. You're gonna use converters, which will fail typically, so it means redeployment. Same story here. So that is also a real problem, not imaginary, but the more specific things you use from public cloud providers, the less flexible or mobile that is, or the amount of effort to make it mobile increases.
Yeah, but this is, I mean, I believe that in this case, it's a bit different because the Kubernetes cluster is the, let's say, the heart of the solution. Where it runs may be bare metal on Azure, or EC2 instances on Amazon, it doesn't really matter. I mean, I have to understand the underlying technologies so that I can configure the networking correctly, even on the cloud provider or internally if I'm using. But the point is that if I start with the, let's say, vanilla Kubernetes cluster and I add this extension, so it's basically another layer of abstraction of the underlying infrastructure.
Yeah,
okay? So with the extensibility, if my Kubernetes clusters are configured with the same extensions, maybe on-prem, cloud, it doesn't matter, or even inside my on-prem deployments, then this application migration becomes much easier.
Yeah,
okay?
yeah. And that's exactly what I meant. These extensions are, let's say, the gotchas or the potholes, whatever we call them. You know, the more specific to the vendor, to the public cloud provider extension, yeah, that's gonna break the portability. That's what my point was. Yeah.
But there is still, let's say, the basic laws that are the same as they were before, okay? If I have my application that relies on, I don't know, terabytes of data, okay, I cannot just like this migrate all the data into the cloud from my on-prem infrastructure.
Yeah,
okay?
sure.
It has to be the replication layer. Okay, there are new technologies with which you can solve. So it's not, you don't have to solve this on the storage level directly, but you have, I don't know, these object stores and so on. It's a new way or cloud native way of developing the application. Okay. Yeah. So when I mentioned before, it's really important that you understand what are you trying to achieve. Okay. I have a list of applications. I don't know, are they applicable to be containerized today, or do I have to refactor, rewrite them, change certain components or whatever? And based on this, it's the functionality side that dictates what I'm going to do, okay? On the near conscious side, we have professional services. We also have assistants. So if you have any issues, we can help you with that. Or even on the managed services side, we can get involved. And we can definitely help you go through this, as Mitja mentioned, through this journey of, okay, I heard that this is great, to the point where I can actually start consuming the whole thing. The last but not least.
Yeah, so there is a question actually, let me read it. Can you adopt vanilla Kubernetes clusters with Tanzu and vice versa? Can you migrate to something like Rancher?
Yeah.
So the first one is, sorry. Can you adopt vanilla Kubernetes clusters with Tanzu?
Yeah.
Oh, sorry. This question has been answered verbally, was the, I guess.
We mentioned it. Okay,
indeed.
maybe once again quickly. There's another question.
Yeah.
So yeah, Tanzu Mission Control is the management portion, and they do allow you. So the Tanzu Mission Control and supports attaching vanilla Kubernetes clusters into this Tanzu Mission Control. Okay, so yeah, that's possible.
Yeah. But remember, sorry, Tanzu Basic doesn't.
Yeah, sure. It depends. Yeah,
it depends on the packaging, let's say.
But so yeah, it's possible. What functionalities do you gain? Maybe you cannot do everything, but yeah, in theory, it's possible. I mean, Cisco is promising the same. Microsoft already with their Azure Arc. This is like a, it's a big product. The intention is for cross-management, single pane of glass, either if you have on-prem deployments, if you have virtual machines, it doesn't matter, containers, whatever, you can manage this with the infrastructure with Azure Arc product. Yeah, so there are different ways of doing things.
Being the devil's advocate, that's another unicorn, let's say.
But you have to have high
high hopes and high goals.
High goals, yeah.
Yeah.
So
the second part was, and maybe that was already answered. Vice versa, can you migrate to something like Rancher?
Yeah, of course you can, if the functionalities are if the Rancher or the Kubernetes level offers the same functionalities, of course, but you have to again think of how you're going to migrate the data, when to migrate it, and so on. Yeah, but I believe it's more than doable. Yeah.
So yeah,
as we are approaching the end of the webinar. So if you have any questions, you can contact directly Mitja or myself, or if you want to talk to our sales department, there's a consulting@nil.com if you have any other questions, or if you want to further discuss something with us. And with that, I guess we're concluding this webinar.
Yeah. If there are no other questions, thank you for attendance. And yeah, see you on I don't know, live in person, tracking the nuts of
Tracking the unicorns.
The unicorns, yes, or catching them. Thank you.
Thanks.
Bye.